Welcome back to NAROJ Academy. Today we are going to discuss the lecture number 5 of electricity chapter. In this session, we are going to discuss about how to connect the resistors in parallel and as well as in series, and what is the equivalent resistance when they are connected in series or parallel, okay, or the combination both. Now we can see that old CRT televisions, is it right? And you can see that complete picture of the TV and the back side of this. Instead, you can see that there is a motherboard and which is having the infinite number of devices are there like resistor, capacitance, etc. Is it right? So here, this is what we call a picture tube, which we can see here. Is it right? So this is the picture tube where we'll get the picture of the any image, and here we can see that speaker and the basic power circuit. Is it right? Device like television, which is a combination of many components, and every component requires a different amount of current. It is not like that every component has a equal amount of current required, but we know that each component like speaker will require different amount of current and picture will require different amount of current. In this basic circuit, each part will require different amount of current. Is it right? So how can different current be provided to the different components? Yes, by using resistor. Is it right? So we can provide the different amount of current by using resistor. So resistor is nothing but which oppose the current. So resistors can be connected in two ways. One is series connection, another is parallel connection. Is it right? Series means one after the other. You can see like this: R1, R2, R3. Whereas parallel means, here you can see that in series connection, you can see the power supply is going from the battery to the first R1 and then R2 and then R3 and then goes to the negative terminal. Is it right? So current in the circuit remains the same. Current is not gets divided here. Okay, current is constant. And between two common points is parallel. You can see that the common points are A and B here, and R1, R2, R3 are the three different resistors. Here, when the current is coming from the battery, you can see that it is getting divided. Is it right? So simply, current gets divided when they are connected in parallel. So here, the total amount of current which is getting is I. It is divided into I1, I2, and I3. Is it right? So like this, they are getting divided. And now, in case of this one, the amount of current which is getting here is I, and as it is, I is flowing through all the resistors at a time, one after one. So in series connection, I is constant. In parallel connection, and V is constant. Okay. So in this, the potential difference across these 2 points is constant between point A and point B. But whereas in this connection, V1 and here it is V2, here it is V3. Voltage is not constant, voltage is variable. Okay, that is potential difference, and current is constant in series. So current gets divided, but potential difference remains the same in the parallel connection. Okay, that is nothing but voltage. Voltage drop is there. We can say constant. Derivation of a formula for the effective resistance of the three resistors connected in series, and prove that there is a chance to ask in exam. So many times this question has been asked, and based on this, the problems also they may ask in exam. Derivation for equivalent resistance in series: Rs is equal to R1 plus R2 plus R3 when they are connected in series. Okay, how to derive this? Very easy steps and very easy to derive this. Okay. So first take three different resistors R1, R2 and R3. Okay, and connect to a battery. You can see that positive and negative terminal are there, and a key and a ammeter which is connected in series here. Okay, and now you can see that current is not getting divided, current is constant throughout the circuit. Always connect the ammeter positive terminal to the power supply side and negative is another side. And here voltmeter has to be connected to each different resistors V1, V2 and V3. Okay. Now according to Ohm's law we have to check. So here equivalent resistance, equivalent voltage difference is V. V is equal to V1 plus V2 plus V3. Sum of the three voltages. Is it right? So V is equal to what? V1 plus V2 plus V3. We know that very well according to Ohm's law. V is equal to IR. Then V1 is equal to what? I into R1. Why not I1? Means here I1 is equal to I2 is equal to I3 is equal to I only. And V2 is equal to IR2. V3 is equal to IR3. We know that in this circuit, we have seen that current is constant throughout the circuit. So I, which is getting here from the ammeter through this, and I1 is here, I2 is here, I3 is here. The same amount is flowing. So I is also equal to I1 is also equal to I2 is also equal to I3. So instead of I1, we can write I. Instead of I2, we can also write it here I. And instead of I3 also, we can substitute as I only. Is it right? So substituting the value of V1, V2, V3 and V in the equation 1, we get V is nothing but what? I into RS. That is R connected in series. Okay. So V is equal to IR. So that I into RS is equal to IR1 plus IR2 plus IR3. Is it right? So what we can take common here? Can be taken common. So IRS is equal to I into R1 plus R2 plus R3. So I gets cancelled. So here RS is equal to R1 plus R2 plus R3. Is it right? So this is a what we can say equivalent resistance when they are connected in series combination. Is it right? So where RS is the effective resistance in series. For n number of resistors, we have Rs is equal to R1 plus R2 plus and so on up to Rn. So effective resistance for in series is the sum of the individual resistance are connected in series. Is it right? You can take the screenshot of this and draw the diagram and make the required connection here. So this is a simple diagram. Here what is there? Key is off now, so the no power supply will takes place here. So we have to switch on it, and then voltmeter never gets connected in series, so we have to replace it with ammeter. And here it has to be plus and it has to be minus. And ammeter always net connects in series but not parallel, so we have to replace this with voltmeter. And here you can connect minus plus. So power supply side is plus and another side is minus. Okay, so this is the required changes in the circuit. Okay, write the derivation of resistance in series and you will get 3 minutes time. Okay, you can do it fast. So here this is the equivalent resistance for this, and your 3 minutes time is over. You can copy this answer or you can cross check with your answer and derive a derivation of a formula for the effective resistance for the three resistors connected in parallel and prove that. Okay, so just before we have seen that the resistors are connected in series, Rs is equal to what we got? 1 by not 1 by, so this is R1 plus R2 plus R3. Is it right? In this connection we have seen that what is constant? I is constant. Is it right? I is equal to constant. But in parallel connection, we can see that 1 by R parallel connection is equal to effective resistance in parallel is 1 by R1 plus 1 by R2 plus 1 by R3 if three resistors are connected in parallel. Okay. If infinity are there means up to infinity 1 by Rn we can say directly. Is it right? We'll see how to derive it. But in this case, we have to maintain the constant is voltage. V is equal to constant. Okay. So V1 is equal to V2 is equal to V3 is also equal to V. Is it right? And I is equal to I1 plus I2 plus I3 in this case. Is it right? So according to Ohm's law, we have to follow the same steps. First, we need to draw the circuit diagram and connect to a battery, ammeter, voltmeter, and so on. Okay. So the current is getting divided I1, I2, I3. So we know that voltmeter measures the what we can say voltage. It is constant here, and ammeter measure the current, which is it gets divided here. So here you can see that I is equal to I1 plus I2 plus I3, and according to Ohm's law, we know that V is equal to what? IR. Then I is equal to what from this? V by R. Is it right? So for I is equal to V by RP when it is connected in parallel, so we can represent like this. Then I1 is equal to V by R1. V is constant. So V by R1 and I2 is equal to V by R2 and I3 is equal to V by R3. Now substitute these four values, first one, second one, third one and the fourth one in the above equation. So here by substituting this value we will get V by Rp is equal to V by R1 plus V by R2 plus V by R3. Is it right? Now we can take V common on the right hand side. So 1 by R1 plus 1 by R2 plus 1 by R3 and so on. So V gets cancelled. So 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Is it right? So where Rp is the effective resistance in parallel. For N resistors, it will be 1 by Rn up to. Is it right? So this reciprocal of the effective resistance in parallel Rp is the sum of the reciprocals of the individual resistors. Okay. Now write the derivation of this resistors in parallel. So you will get the 3 minutes time. So fulfill this. So we know that here I1, I2 plus I3 and here V by R1 and here V by R2, R3 and then V by Rp is equal to V by R1 plus V by R2 plus V by R3. Okay, V gets cancelled. So Rp 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay, so this is the equivalent resistance when three resistors are connected in parallel. Okay, so how are the appliances connected at home in series or parallel? So we know very well when we connect in series, all the devices will require the same amount of current. So there is no chance to connect in series. So we have to connect them in parallel only. So what will happen if the appliances are connected in series? So first of all, if you can see that the current is flowing through the refrigerator and then TV and then iron box. Is it right? So what happens if the power supply gets disconnected somewhere at refrigerator? Is it possible to see the picture through the TV and as well as is it possible to work the iron box? No. So this is the one disadvantage where if one appliance gets damaged or one appliance power supply gets disconnected, then other appliances won't work when they are connected in series. Is it right? So if one appliance is switched off, all the appliances will be off. Hence, at home appliances are not connected in series. Is it right? So what happens if the appliances are connected in parallel? You can see that the same appliances, the refrigerator, TV, and iron box, when the current is supplied from the main source, it is getting divided into all the appliances. Is that right? So different current flows through the fridge, TV, and iron. So here, if the TV is off, still the remaining two devices gets worked. So if one appliance is switched off, another appliances will still work. Hence, at the home appliances are connected in parallel. Is it clear? So how meter is at our home connected? You can see that we're having series, parallel and mixed. Is it right? So already it has to connect it in series only. Why? Because the total amount of current which is coming from the main supply has to be measured by this meter. So it has to be connected in the series only. The current that flows in our house that has to flow from meter only. Okay. How our appliances are connected in drawing room? We know that always they are connected in parallel only. Is it right? Parallel is the right answer. If one switch is on, only one appliances will work. What are the advantages of connecting electrical devices in parallel with a battery instead of connecting them in series? First, when the number of electrical devices are connected in parallel, each device gets the same potential as the supplied voltage. Due to this, other devices are not affected if one device fails in series connection. If one device fails, the circuit breaks and then others stops working. Is it right? The parallel circuit divides the current through the circuit electrical devices. Thus, each device gets proper current depending on its resistance. Whereas in series circuit, the same current flows through all the devices irrespective of their resistance. So the total circuit resistance can be reduced by connecting the devices in parallel. Is it right? Thank you.